Thank you for joining me today, mathematicians, as we go through and we try to show that the derivative of the square root of x is indeed 1 over 2 square roots of x using the limit definition of derivative. So where we need to start off is we need to actually recall the limit definition of derivative. And what we're going to have is that, in general, the derivative of a function is going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. So now the point here is that if we were at a point, say a, we would take f of a plus h minus f of a would be the change in the y value divided by the change in the x value is going to give me my slope of my secant line. And since I'm taking the limit as the change gets small, I get the limit of the slopes of secant lines. So it's going to give me the slope of the tangent line. So the derivative of the point is the slope of the tangent line. If I want it as a function, then I just let x be variable. And so then I can find the derivative or the slope of the tangent line at any given point for x by finding the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, in order to do this, there's actually a lot going on here. We have to find f of x plus h and f of h and divide and take the limit as h goes to 0. And so I find the hardest part about these problems is just doing a lot of algebra. It's not calculus, it's just doing algebra and simplifying so that I get out what I'm looking for. And so now as I do this, I really don't like to do everything at once because I tend to make a lot of mistakes. So I like to break this into multiple steps so that I have small pieces to work on. The smaller pieces I work on, the less likely it is I am to make mistakes. All right, the first piece I'm going to work on is taking my limit definition of derivative. I'm going to look at, okay, well, there's a lot going on here, so let's break it into smaller pieces. And the smallest pieces I see are h. Well, I know what h is. F of x, I know what that is. So the first thing I really need to find is f of x plus h. So my first step here is going to be find f of x plus h. So if I do that, all I'm doing is I'm taking x plus h and plugging it in for x into my function, which in this case is the thing I'm taking the derivative of. That is the square root of x. So my function is the square root of x. And so notice here what I'm doing is instead of x, I'm just writing a parenthesis to say, well, this function is take the square root of whatever I plug in. But now in this case, what I'm plugging in is I'm plugging in x plus h. So instead of writing x here, I'm going to write x plus h. And what I get is the square root of x plus h. Now, if I could, I would simplify this, but I can't distribute the square root. I can't do anything else. So what I'm left with is just f of x plus h is the square root of x plus h. And because that's as simplified as I can get, I would move on to step 2. Then step 2 is going to be f of x plus h minus f of x. So what we're going to get here is I'm going to use what I had from the first step and recall that f of x plus h is just the square root of x plus h. And f of x is just the square root of x. So I'm just taking the square root of x plus h minus the square root of x. Now as we look at that, we would say, can I simplify this at all? If I can, I'm going to. And it doesn't look like I'm really going to be able to simplify this. However, we know that we're going to end up taking a limit. And when we took limits with square roots, if you look back at that video, you'll notice that, well, in order to simplify and get rid of square roots, we had to end up multiplying by the conjugate. So instead of waiting until I take a limit and having to do more than one step at a time, I'm going to realize, okay, I know I'm going to need a limit, so I'm going to have to multiply by the conjugate. And if I do that on top, I have to do that on bottom. So to simplify f of x plus h minus f of x, I'm actually going to multiply by the square root of x plus h plus the square root of x. That is, I'm taking this term and changing the minus to a plus. And because I did that on top, I have to do that on bottom. So I get the square root of x plus h plus the square root of x. And now I can actually multiply that out to try to simplify this. And what I'm going to end up with is, well, the square root of x plus h times the square root of x plus h is just x plus h. Square root of x plus h times the square root of x minus the square root of x times the square root of x plus h are, well, those are the same terms. There's just one's positive, one's negative, so they cancel out. And I get negative square root of x times positive square root of x is just, well, negative times a positive is negative. The square root times the square root becomes the original. so I just get x. Now, I still had over the square root of x plus h plus the square root of x. So I'm pulling that down as well. And now I can simplify just a little bit more and notice that I have an x minus an x. So if I cancel those out, I'm left with h over the square root of x plus h plus the square root of x. And now I've simplified this step as much as I can, so I'll move on to the next step. All right, now for my third step, what I'm going to do is take f of x plus h minus f of x and then all divided by h. So I've already found f of x plus h minus f of x is just going to be h over the square root of x plus h plus the square root of x. Now I could divide the whole thing by h, but in general it's a little bit easier to say, since I'm going to divide fractions anyway, I'm going to multiply by the reciprocal. So instead of dividing by h, I'm just going to multiply by 1 over h to begin with, because it's going to help me keep track of what's going on, and it's actually generally going to cause fewer problems than trying to divide by h. Once I see that, though, notice that what I have is an h divided by an h, and so what I would get is, well, as long as h is not 0, I get that this is just 1 over the square root of x plus h plus the square root of x. And so I'm going to say that's true as long as h is not 0. Now, I do need this here because if I don't write it, then these two things aren't the same, because we have h over h is not defined at 0, whereas this would be. So I do have to say h is not 0. But if we look ahead, we're going to end up taking the limit, so we don't actually need to worry about what happens at 0, just as we get close to 0. So what we found was that if we look ahead, the inside of the limit is just going to be this, because I am taking the limit as h goes to 0. So then we'll go ahead and do that in the next step. All right, so if we combine the work that we had, what we realized is that we wanted to find the derivative, which was the limit as h goes to 0, of f of x plus h minus f of x over h. And we had found that as long as h is not 0, the inside is just going to be 1 over the square root of x plus h plus the square root of x. And since we're taking the limit, we don't need to worry about h equals 0, just close to 0. Therefore, what we've done is we've simplified the problem so that we now have a new limit. So to calculate this new limit, what I want to do is plug in 0 and see what I get out. In that case, what I'm going to get is 1 over the square root of x plus 0 plus the square root of x. Now notice here that yes, we do have x as a variable, but x doesn't change with respect to h, so we're actually going to count x as a constant. That is, it's going to be treated as if it was a number. So what we get is 1 over the square root of x plus the square root of x is indeed just a number. So when we took this limit, we got out a number, so that would mean that that is our limit. And so just combining these two together, I have one of these and one of these, so I get 2 square roots of x. What I get is that this limit as h goes to 0 is going to be 1 over 2 square roots of x. Therefore, we've shown the derivative is 1 over 2 square roots of x, which is precisely what we were planning on showing to begin with, and so we get out what we were looking for. Thank you for joining me today. I hope you learned something and enjoyed the process. If you did, make sure to like the video and subscribe to the channel. It all helps to make sure that we can get this out to anyone else who needs calculus help.